Math 3, Unit 4, Section B. So this next set of notes, we are talking about combining radical expressions by products or by multiplication. Okay. So the first thing is that you have to have the same index. So notice here, you can only combine them if your roots are the same or your index is the same. So we're just going to kind of make a note here. Index / root needs to be the same. If they aren't, then you can't multiply them. All right, so moving to A. Those both have the same index of 3. When I simplify that one, do I have to worry? Well, first of all, you don't have to worry about absolute values when you're just dealing with numbers. You only have to worry about absolute values when you have variables, right? Okay, so what I end up doing is I like to write these under one root. So this really is the cubed root of 4 times 16. So since they both have a cubed root, you can put everything under the same one. Some people like to multiply those numbers together. I personally don't like to multiply them together because I know I'm going to have to break them up into a factor tree anyways. Does that kind of make sense? And so then this means I need 3 for the group, right? So 16 breaks down to 4 and 4. And so I have a group of 4s, which means my answer is 4. There's nothing left over. Yes. On this one, I wanted to kind of make a note because notice how we have negatives under here. These negatives are okay because it's an good. If it was even, it might not work out the same way because these separately would end up making imaginary numbers. Okay? So if we were to write this out, this is really the cubed root of negative 12 times negative 18. Now, what happens when you end up multiplying a negative times a negative? It makes a positive. So this really is now the cubed root of 12 times 18. Now, if you want to multiply them together, that is totally fine. If you don't want to, that's fine too. If I were to break this down, this one is 2 and 6, and then 6 is 2 and 3, right? 18 is 6 and 3, and then 6 is 2 and 3. So we need 3 for a group, and so you can see I do have 3 2s, and then I also have my 3 3s. So when I bring that out, my answer ends up becoming what? 6. Okay, questions? All right, so these next examples are when we're dealing with variables as well. So I'm just going to make a note here to pay attention to index / root and variables. Absolute values, bars may be needed. And again, I write all this stuff in your notes because as you look back at them when you're trying to complete the homework, hopefully the notes will help you remember why things are the way they are. Okay, so this first one is a cubed root. Do I have to worry about absolute value bars? No. Okay, only even roots. Okay, so we're like, awesome, I don't have to think anymore, I can just do the problem. Okay, so 128, if you're ever not sure about a number and it ends with an even number, you know it's divisible by 2. So this is 64 and 2. And then do you guys know that 64 is really 4 times 4 times 4? And so I like to just write this out as 4, 4, and 4 instead of doing like 16 and 4 and this and that. So we have a group of 4s, and notice the 2 doesn't have a group. I always end up putting a box around anything that doesn't have a group to remind me that it's going to go back into the radical. Okay? Yes?
You can't like separate the 4 again.
You could, but you'll end up with a group of 2s and another groups of 2s, which will end up making a 4. So it's up to you. I just like to do less work if I don't, you know what I mean? Okay. And then how will I write out the x to the 7th? So we need how many for a group? 3, right? Because it's a cubed root. And so this means I'd have x to the 3rd and x to the 3rd, and that makes 6, right? And so how many will I end up having left over? Just 1, just an x. And so I'm going to box an x. So again, all of those numbers should end up adding to be, make that a little bigger. Is that any better? These need to add to be 7, which they do, right? 3, 3, and 1 make 7. So anything that can't make a group gets boxed. So when I write this answer, how will I write it? What's going to go on the outside? So you have your group of 4, right? So you're going to have 4. And then when you have 2 groups of x's, I write that as x to what? X to the 2nd power. When you write your leftover root, you need to make sure you keep the same index. Also, make sure that that number is going inside your radical little bar thing. Otherwise, it looks like it's a number 3. So it's really like a little number inside that, letting you know that the index is 3. Okay? And then what is left under my radical? 2x. And again, and we might want to write a note here, no absolute value, odd index. Okay, so again, next one. Are we going to have to worry about any absolute value bars? No, because it's an odd index. Okay, so 81, what am I going to break that down to? 9 and 9, and then each 9 is 3 and 3. So I have 4 3s, but I need how many for a group? 3. Gabby, are you getting this? And so how many do I have left over? Mm-hmm. And then what about the x's? Good, there's 3 x's, so I'm just going to circle those because that makes one group and there's nothing left over. So how will I write this answer? Good, so I have a group of 3's and I have a group of x's, so that's just 3x. And then we write the cubed root, and again, don't forget your index. And then the only thing left inside is what? 3. Okay, and if you want to, you can put an arrow here. Same information, no absolute value, odd index. Okay, next one. What do you notice? Even index, which means I may need absolute values. Okay? Have you guys seen like that little caret symbol before? That also means exponent. So this really is the same thing as the 4th root of 64 x to the 3rd y to the 6th. So I just wanted you to see that sometimes you'll see it written with the little caret sign, but that means exponent or power, okay? All right, so let's break this down. So what will 64 break down to be? 64 could be 3/4, okay? And then from there, we would break those down because we need how many for a group? 4, and I have only 3 4s. And so I'm going to break these all down to 2's. So I'm going to end up with how many 2's? 6. Okay, so here's one group of 2's, and then I'm going to box these 2 2's that are left over. X to the 3rd. Can I take out any group from that? Nope. So I'm just going to go ahead and box that one because it's going to stay under my radical. And then y to the 6th, I'm going to break that down to what? How many do I need for a group? 4. So I'm going to write this as y to the 4th, and then how many would I have left over? Good. And I'm going to box that. So again, all of my groups, my circles get taken out, and any boxes that are left over stay inside my box, like my radical. Okay? So when I bring those out, we have 2. We don't have to worry about absolute values with numbers, so we have a 2. And then I have y to the 4th, and that's one group. When I bring that out, is that going to be an even or an odd exponent? It's going to be an odd exponent, right? Because it's just y. That y to the 4th becomes just 1y, right? Well, since it's only 1y, it's an even exponent of 1. That means I will need an absolute value around it. If that had been y to the 2nd power, then I wouldn't have needed it. Okay? And then I end with my 4th root. And then inside, if I have 2 times 2, that's actually 4. And then what else is left in the box? X cubed and y squared. Okay, so again, let's go ahead and write a note. Absolute value needed. Even index and even power in root. Because when it starts out, it has to be an even power in here and an even power out here. Remember how they said both of them had to be even? So if this was an odd, like even the x, if it starts out as odd, you don't end up needing absolute values. So even index and even power in root, and then odd power when it came out. Okay, we good? All right, moving on. So again, when you're multiplying, all these end up getting put together, okay? So I like to just rewrite this as one radical. I don't normally multiply my numbers, it's up to you. So I have 45 times 35. And then how many total x's do I have? 6. Because I have 5 and 1. This y, it should be just a regular y to the 3rd. So I have y to the 3rd and y to the 4th, which makes y to the 7th. Okay? And so this is a square root.
Elijah Ortiz, please report to the attendance office. Elijah Ortiz, please report
So we
to the
have
attendance
to
office.
remember that there's a chance, because it's an even root, we might have to use absolute value bars. Okay? See how this one's even? The only one I have to worry about is the x's. Since 7 is odd, I do not have to worry about the y's. Okay? So it's only when you have an even index and an even power inside. So you might even like circle some of them. I only have to worry about the x being in absolute value bars. Okay? And so 45, what does that break down to be? 9 and 5, and then 9 is 3 and 3. So I have a group of 3s right now. 35 breaks down to 5 and 7. Good. And so I have a group of 5s, and it looks like I'm going to have a 7 left over. Okay. Now, how many groups of x's will I have?
Don't you have a 9 left over too?
Do I have a 9?
Yeah, left over. Oh, no, never mind, because it was broken down.
Yeah. Okay. Good. All right. So I'm going to write these as x squared, x squared, x squared. Right, because I need 2 for a group, and there's nothing left over, and 2 plus 2 plus 2, that all makes 6. With the y's, I'm going to do y squared, and a y, because That one doesn't have a group, and it's left over, and those all add up to make 7. So when I write my answer, we have a 3 and a 5 that are being brought out, so that becomes what? 15. And then x will be to the third. I'm just going to write this way for right now. Y will be to the third. And inside my root, I'm going to write 7y. Good. Okay, so does anything need absolute value bars? Does the x need an absolute value bar?
Yes.
Yes. Because it's odd when it came out. Okay, so again, I'm going to put here even root and exponent for x. Okay? Odd power when out of root needs absolute value. I hope that makes sense. So at the very beginning, I'm talking about even root and even exponent for the x. Okay? And so because it's even and when it got brought out, it was odd, we have to use the absolute values. Okay, the next one on B, they are odd roots. So do I have to worry about absolute value at all? No, because it has an odd index, we're good. Now notice here, this has a negative on the outside and a 2 on the outside. So when I multiply those together, I end up with what? So -2 cubed root of, and then we have 2 times 15 times, and then it's x to what power? 7th, and these are supposed to be like a regular y squared, and this is a regular y. So we have x to the 7th, and then y to the 3rd. If I break down 15, 15 breaks down to be 5 and 3. Are there any pairs? No. So like all of these are basically box and left over because there's no groups. Okay? Then x to the 7, I'm going to break it up to x to the 3rd, x to the 3rd, and x. Because again, my index is 3, so I need 3 for a group. And then my y's, it's only 3, so I just have one group of y's. So when I write this answer, on the outside, what am I going to have? -2, right? Because you still have the -2 that's out in front. And then x squared, because there's 2 groups of x's. And then y, because there's 1 group of y's. And then we have the cubed root. And what is left inside? Good. 15x. No, not 15x, sorry. 30x. Because we have 2 times 5 times 3. And if you want to write no absolute value, odd root. Okay, so far so good? Okay, next problem. Okay, what do we do here? So on the outside, I'm going to just have what? 3. And then it's 4th root.
We can't see it.
Thank you. Okay, 3. And then we have the 4th root. And so I'm just going to write 18 times 6. And then a is to what power? 10th. And then b is to the 2nd. Okay, so this is an even root. Okay, so we have an even root or an even index, and this is an even exponent, and this is an even exponent. So since they're all even, there is a chance that I might need absolute value bars. Okay, so breaking down, 18 breaks down to what? 6 and 3. And then 6 would break down to 3 and 2. And then over here, this 6 is going to break down to 3 and 2. Is there 4 of anything? No. Okay? And so all of that's going to end up staying. And if you want to go back and just multiply, what is 18 times 6? It's 108. So I'm just going to cross this out and write 108 with a box. Because remember how last time we messed up with 15 and 30? It might be easier if you have a bunch of numbers left over, you just multiply them together and put it there. Okay, how will I break up A to the 10th? We need how many for a group? So that will be 4, right? And then another 4 makes 8, which means I would just have squared. Good. So I have 2 groups and then A squared left over. And then B squared, I can't do anything, right? So that one's just left over. So how am I going to write this answer? 3A to the 2nd power. And then we have the 4th root of 108 A squared B squared. Okay. How many think we need to put absolute values around A squared? How many think we don't need to? Okay, and a lot of you are not answering. Okay, so why don't I need absolute value bars?
Because it's even.
Because it's even when we brought it out. Very good. So let's just write that. No absolute needed even power when out of root.